this video we will be solving problem number 746, minimum cost climbing stairs. So we are given with an integer array called cost, and cost of I represents the cost of ith step on staircase, and once we pay that cost on a specific staircase we can jump by one or two steps to move further. Also, we can start from index 0 or from index 1, that's up to us. And we has to find what is the minimum cost to reach from bottom to the top of the floor. So we are given with two examples. For the first output is 15 and for the second output is 6. So using this diagram we'll see how we are getting those answers. So in the first example, which is 10, 15, 20, I have created this staircase where 0th index has cost 10, first index has cost 15, and second index has cost 20. We are standing below 0th index, so that I am calling a start, and we has to reach after second index, we are calling it end. So from here we can take one step or two step. So these are the four paths that we can take. So from start we can take one step, then another one step, then another one step. So we accumulated 10, 15, 20, which is 45. In the second way we can go to 10, then from here we can take jump two steps, and from 20 we can take one step to go out of the array or top of the floor. So in this case we accumulated 10 plus 20, 30. In the third case we directly jumped to the first index. We took two steps, and then we took one step, and then to the end. So it took us 35. In the fourth case we jumped to the first index and costed 15, and then took two steps to get out of this staircase and reach the top, and we only paid 15. So between four ways 15 is the minimum, so that's why here for the first case 15 was the answer. Similarly, in the second case we have again drawn this long staircase, and we can take lot of options. I haven't mentioned them all, and we went to 0th index, then we went to second, then fourth, then sixth. So the only constraint is we can take either one step or two steps. So intentionally we have skipped 100 because that will blow up our cost. So that's why intentionally we have taken one wherever we can, and then we have managed to get the cost of only 6, although there were several hundreds, and we paid only 6, and each step was costing us 1. So this is the problem. To solve this problem, what we can do is we can extend this step model into a decision tree and then understand further. So we are given with cost 10, 15, 20. Total number of cost given is 3, and output for this was 15. So this is the tree that we can draw. So from 0 we went to first index, which costed 15. Similarly we can go to 2. Similarly from 2 we can go to 3 or 4, because we can take one step or two steps. Similarly this tree is created, and each path from root to the leaf gives us the cost that we has to pay. So if we take this path we'll pay 10, 15, 20. Similarly if we take this path we'll pay 10 and 15. So between all these we has to find which is the minimum path I can take from 0 to 0 or 1, because we can start from 0th index or first index. That's why this is the tree when we start from 0, and this is the tree when we start from 1. So this branch has been created here again, and between all the paths this is the path which cost us minimum. It cost us only 15. So we start from first index and then we go to 3, because we can take one step or two step. In this case we'll take two step directly, and we'll go out of the array bounds, which is top of the floor, so it will cost us only 15. So seeing this, what we can do is we can write a recursive solution. So before going into the solution, I would like to mention that whenever we are seeing a problem wherein we can boil down to tree-like structure, and we see that to get the bigger result, we can solve smaller problems. Like for getting to, what we can do is we can solve this sub problems. This indicates that this problem can be solved using DP techniques, dynamic programming techniques. So that's what we'll be using. So we'll simulate this tree-like structure into our code, and then we'll see complexity and see other approaches. So first of all, I'll create another internal function which will take index, which keeps track of where I am currently. And if idx is more than equal to length of cost, which means that I am already at the top of the floor, I don't have to pay anything, 0. Otherwise, I has to pay the cost of the current step that I am in, and minimum of the two steps that I took, which is idx plus 1 or min cost idx plus 2. And at the end, we have to call this function also. So we will call this function using, again it will be min cost 0, because we can start from 0th index or first index. That's it. This should work. Yeah, it works for both the examples. But before submitting, I would like to talk about the complexity of this problem. So here we see that for each index we are calling the same function twice, which is same, which has been mentioned in this tree and this tree. So from every step we are taking two further steps. We have two options. So height of this tree will be 3 if I am counting the number of edges. So we have 3 edges, and 3 is equal to the number of steps. So here we had 3 steps, so the height of the tree was 3. And this is actually a binary tree, or in fact balanced binary tree. And if the height of a balanced binary tree is n, the total number of nodes that are possible in that tree will be 2 raised to power n. So the complexity of this solution will be 2 raised to power n, and that is exponential, and it won't allow to submit us. So there is a scope of optimization in this. So from this tree, what we see is there are several nodes that are repeated. So if we see that 2 is coming here also, 2 is coming here also, and in a bigger tree there would lot number of nodes that are repeated. Let's say if cost is 10, there would be several number of nodes that are repeated again and again. So what we can do is, instead of calculating the result again and again for the same number, we can cache those results. So for caching, we can simply use a hash map, and we can save the result into it. So we'll take this empty dictionary in Python. In other languages, there would be other ways to use this hash map or dictionary. And if we see that if this index is already present in cache, we don't have to calculate again. We can return the result from the cache itself. And very important, we have to update this cache also. So what we'll do, we'll update this cache with the value, and in the end we'll return this cache. Now let me try to run this code. Yeah, bit ran, I try to submit it. Yeah, it got submitted. So the time complexity now reduces to order of n, because for each and every input we are calculating only once. We are not recomputing again and again. So that's why it is saving us from exponential time complexity, and we are only having time complexity of order of n. And space complexity is also order of n, because we are using this cache to save the previous results and reuse it later. So this is the first approach to solve this problem. In DP, whatever we can do in top-down approach, which is the first approach that we saw, top-down, or we call it recursive plus memoization. So that can be solved using the bottom-up approach, wherein we take a DP array and then keep on populating that array, and then eventually we get the result. So we'll be solving using that approach. So I'll reset this. So here what we'll do is we'll take len of cost, then we'll initialize a DP array. We'll take n plus 1 size of array. We'll see how that helps. And then we'll start from second index, because for the first two we already have the result. We can either start from 0 and 1, so that we already know. And then DP index of I will be minimum of two results which have been calculated earlier. And as we know that we can take one step or two step, so that's why we'll do idx of -1 plus cost idx of -1, and then let me just copy idx of -2 and cost of -2, because we can jump one step or two steps. So my current index solution will depend on my past two indexes solution. That's why we are taking -1 and -2 cost, as well as the result that I have already calculated in the past, which is represented by index of -1 -2. And then at the end we'll return dp of n. So that's why I'm calculating for the index n also, and will be calculating that using index of -1 and index of -2. So that's it for this solution. The time complexity remains same, because we are iterating the cost array only once, and we are taking space also, which is dp of size n. So that's why both remains the same. It's just that this is non-recursive solution. Run. Yeah, submit. Yeah, this is also accepted. So this solution is works well. Now there is third approach also, not exactly an approach. There is an optimization that we can do with this approach also in terms of space complexity. So the observation for this is if we take this DP array, we are only using last calculated value or last to last calculated value. We are not accessing this DP array randomly. That's why we can take two variables and save those results somewhere, and then we can use that. So we'll be doing that in this approach. We'll get rid of this array and we'll call away1 and away2 and initialize it to 0. And we also take res to keep the result, and then in the end we'll have to return res. And this will be away1 and this will be away 2. So away 1 and away 2 represents 1 away from my current index, and away 2 represents 2 away from my current index. What was the result? That was calculated 2 away from the current index. And we also has to update these two values. So we'll do away of 2 equal to away of 1, and away of 1 equal to rest. So whenever this loop runs again, away 2 becomes my away 1, and my away 1 is the current result that I have calculated. So that's what this update is about. Now we are not using any additional state space. I'll try to run this. Got accepted, and submit this. Yeah, is submitted. So in this approach, the space complexity also reduces to order of 1 or constant, because we are not taking any additional space to solve this problem, and time complexity remains same, order of 1. Also, one thing to mention that this rest will always be created, because the input range is 2 to 1000. So this loop will always execute, because if there are only two values, then also we will be executing from 2 to 3. That's why we don't have to worry about all those things if rest is not created. For this problem, we see three approaches to solve this. So first one was the top-down approach, which was the recursive with memoization, and it took order of n, time and space. The second approach was to convert this recursive program into iterative one, which is called bottom-up approach, and it uses DP table or DP array, and it took same time and space complexity of order of n. And the final approach, which was space optimized, this was also bottom up, and it was space optimized and took order n time and order of 1 space. So that's it for this video. See you in the next one.